Hey there, we are going to start our lesson off with how to find equivalent fractions using multiplication and division. I know that we kind of hit on that in our last video, but we're also going to look at comparing fractions. How do we know which one is greater than or less than? So in our last video, I showed how you could take and divide pieces and divide a whole into pieces, and you could shade it. And if we have 1/4 here, we could find fractions that were equivalent to 1/4 by continuing to divide our whole. So we could find out that 1/4 was the same as 2/8. We also discussed how you could use a number other than 0 or 1 to multiply your denominator by, and whatever you do to your denominator, you have to do to your numerator, and that would help you get equivalent fractions as well. And we talked about the identity property of multiplication and how really numbers like 2/2, 3/3, 4/4, those are all the same as 1 because they are 4 pieces out of 4 pieces. So when we look at 1/4, we can multiply by 2 2/2, which is 2/2, to get 2/8. We can do this with pretty much any whole number, one equivalent, a fraction that's equivalent to 1, and get an equivalent fraction for what we're working with. So if I have 2/3 and I want to know, what happens if I multiply by 10/10? I would end up with 20/30, and 20/30 is equivalent to 2/3. Your possibilities are endless when you use multiplication to find an equivalent fraction. The same is true, and you're going to learn more about simplifying fractions later on. The same is true with division of fractions. You're going to divide by one whole, which could be any number of parts out of any number of parts. So let's say I have 15/45. If I know my rules of divisibility, I know that 15 and 45 can both be divided by 5. So if I divide by 5 on the top and divide by 5 on the bottom, 5/5 is the same as one whole. 15 divided by 5 is 3. And 45 divided by 5 is 9. I could even simplify more because looking at this number right here, I could actually divide by 3 and 9. I could have started out by, I could divide by 3/3. I could have actually started out by dividing both of these numbers by 15. So I'm going to divide by 3 here, 3/3. And I know that this fraction is equal to 1/3. So 15/45 is equivalent to 3/9, which is also equivalent to 1/3. Now I walked through this process very quickly. So just know when it comes to equivalent fractions, we can multiply by a fraction that is one whole, or we can divide by a fraction that is one whole, and we will end up with equivalent fractions. Remember that equivalent fractions are fractions that have the same value. Equivalent fractions are fractions that have the same value. Now we're going to move on to comparing fractions. So I'm going to write on my paper real quick, comparing fractions. And we're first going to compare fractions using a model. Comparing fractions using a model. When we compare fractions with let's start out. If we compare fractions with like denominators, so if they have the same denominator, our job is really easy. We look at the numerator, and whichever one is greater on the numerator is actually the greater fraction. So look at the numerator. So for instance, let me get my fraction bars out here. If I have 1/2 and I am comparing it to 2/2, my denominators are the same, my numerators are not. 2 is greater than 1, therefore 2/2 is greater than 1/2. When we look at this from the perspective of a model, if I can get my fraction bars out, 2/2 is the same as 1. This is a half. Now, again, when we're looking just at numbers, the assumption is that our whole that we're working with, both wholes that we're comparing, are the same size. So I have the same size candy bar. I'm comparing a regular size Butterfinger to a regular size Butterfinger. I am not comparing a king to a standard. So hopefully that makes sense to you. So we have to assume that your whole that you're starting with is the same size. All right, if we wanted to compare 3/4 to 1/2, again, both of our wholes are going to be the same size. This is what 3/4 looks like, and this is what 1/2 looks like. When we look at that, 3/4 is greater than 1/2. Now, I need you to understand that this is not because of the 4 on the bottom. Look at the size of my pieces. As my denominator gets larger, my pieces get smaller. So when I have something like 4/8 and I'm comparing it to 3/4, you can see that just because it's an eighth doesn't mean that my fraction is going to be larger. I actually have to look at the fact that these pieces are smaller and these pieces are larger. So fourths, if we look at 1/4 against 1/8, 1/4 is quite a bit bigger than 1/8. It takes 2/8 to make 1/4. So again, the assumption when we're comparing fractions is that your whole, the whole of the item that you are comparing, is the same size. The pieces that they're broken into are different sizes. So that's where we're getting the 1/2, 1/4, 1/8. Working with a model makes it really easy. If you have fraction bars and fraction strips, those kinds of things can help you. You can always go online and use virtual fraction bars and fraction strips. Those are available for you, I think, on Math Toys or something like that. It's linked in our Unit 1. It's linked in your Buzz. I know that I've shared the link a couple times, and I will share it again to our resources library as a separate link in our library. So now what happens when we don't have these beautiful fraction tiles and we have to compare numbers? So the fraction tiles and the fraction strips are a great tool to use if you have them. Again, the other thing you can do is, if you don't want to get online and actually manipulate things online, you can find a copy and print out some fraction strips. And again, I will put that resource on your resources page, so that if you want to make a copy of some fraction strips so you can do some comparisons of your own, you can. So we've compared a couple of different things. Let's look at comparing. Hang on, let me go through and look at your lesson real quick. So a blank is an equal part or parts of a whole. We covered that vocabulary in the first video. The bottom number of a fraction, remember, down, 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 denominator, down, 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 denominator. The top number is numerator. Fractions that are equal to the same amount, hopefully you remember that. So you're going to be given some models, and you're going to be asked to match the fraction to the model. Remember that a fraction is a number that represents the number of pieces out of a whole. And this is not like a hole that you dig yourself into. This is a whole as in a complete. So if we have a model that looks like this, and it's divided into two pieces, our whole is in two pieces. If one side of it is shaded, that represents one out of two pieces. Hopefully that makes sense to you. So you have to count the number of pieces in the whole, and you have to count the number of pieces shaded. Let me continue to look at the models. So they're going to give you some fraction models, and they're going to want you to count the pieces. They're going to give you 4 different ones, but you have to find the fraction model that represents what they're asking for. So they may give you something like this, where they have pretend those are all the same size, remember. In a perfect world, these would all be the same size. Okay? The pieces would all be the same size. So they may say something like this: 7/10 is less than 1/2. And you have to decide if 7/10 really is less than 1/2 by looking at these models. Well, if we look at the models, we first have to find which one shows 7/10, which is going to be this one right here, 7/10. And which one shows 1/2, which is the one right above it. Once we look at the model, we can decide, no, this is not true. 7/10 is actually greater than 1/2. All right, let me look through, looking at fractions as models, which fraction. Okay, so another question that you might run into on your lesson might look like this: 3/4 times blank. 3/4 times blank equals 15/20. And you have to figure out what would go in these blanks to make this true. So I know this is the same thing as a turnaround fact or a fact family. So I know that I can move this around and say 15/20 divided by 3/4, because remember, multiplication and division are in the same fact family, equals blank. 15 divided by 3 is 5. 20 divided by 4 is 5. Remember that you are going to get something that is the equivalent to 1. So it will be the two same numbers. When you are approached with finding an equivalent fraction that makes the equation true, you're going to be looking for a whole number that's represented with the same numerator and the same denominator. Okay, same thing where you're going to be given a division problem with a blank in it. So it might look like this: 18/24 divided by blank equals 3/4. And you have to figure out what's going to go in that blank. So you know with division you can switch it around to multiplication, or you can switch it around so that your division is easier to figure out, because we know that if 18 divided by something equals 3/4, 24 divided by 3/4 is going to equal that thing. Or you can turn it around and say 3/4 times what equals 18/24. Hopefully you came up with the answer 6/6. All right, let me check and see if there's anything else we need to cover. All right, you're asked to choose the equivalent fraction, so you're going to have to do some multiplication or division on your own to figure out an equivalent fraction. Remember that when you are trying to find an equivalent fraction, you are multiplying or dividing by a number that represents one whole. Numbers that represent one whole include, but are not limited to, and you can't use 1 or 0, so you can do 2/2, 3/3, 4/4. Ooh, 4/4, not 4/5. My brain got ahead of me. 5/5, 6/6, 1,000,000 1,000,000ths, 1,000 thousandths. Okay, those are all representative of one whole. Remember that if you have any questions after watching this video, please come and see me. Thank you.